Hi guys, today I'm going to give a demonstration on appliance testing. The tools that we're going to need today is the installation resistance tester, a digital multimeter and a calculator. There's two types of appliances. There's a class 1 appliance, which we have here, which is this toaster, and a class 2 appliance. The difference between the two is a class 1 appliance doesn't solely rely on its installation for protection against electric shock. It also relies on the earthing system. Okay, which we can see this is a class 1 appliance because it has the earth pin, which allows it to join the earthing system in the event of fault. Now I've got a class 2 appliance here, and the difference with a class 2 appliance is it doesn't rely on the earthing system, and it doesn't only rely on its basic installation for protection against electric shock. It also has double installation, and how we can tell it's double installation is that it's missing the earth pin. It also has the symbol for double installation on the base here, which is a box within the box. So this is what the double installation symbol means. So if you see that symbol on any appliance, you'll know it's a class 2 appliance, and it doesn't rely on the earthing system. It's not actually, the earthing system's out of the equation. Now, we're going to be doing our testing on the class 1 appliance today. So the first test we do is the visual inspection. Okay, the visual inspection finds 90% of faults. So what I'm going to do is going to rub my hand along the cord. I'm looking for any nicks, okay? And then I'm going to check the base of the plug top, make sure the pins aren't bent, everything's there. You're also looking for any knocks, massive knocks that could potentially damage it. Okay, so that seems fine. The visual inspection is fine. And then what we're going to do is a resistance continuity test. So all we're going to do is we want to check our continuity between the earth pin and any exposed conductive part. So in the event of a fault, the fault current can go down in through the earth cable, in through the earth pin and into the earthing system with minimum resistance. Now the value that we allow is 1 ohm or less. So we're going to get a digital multimeter, we're going to set it on ohms range. Okay. Do one of our probes, and I'm going to put it against the earth terminal and any conductive part that you see. Okay, I'm getting 0.0 ohms. So that's excellent continuity. So we can move on to the next test, which is the resistance functional test. Okay, and what the resistance functional test is, we're basically going to use a power formula with the figures that we're given here in this toaster to decipher what the resistance should be if it works correctly. Alright, so the power formula that we're going to be using is R equals V squared over P. Alright, so then R equals, we already know that's going to be 240 volts because that's what we use in an installation. So R equals 240 squared divided by P. Now we simply find P by looking at the base of the unit, usually a plate, nameplate, any specifications on it, everything is here about it. Now, the manufacturer tells us it's going to be 850 watts. So we now put that into our equation, 850. So R equals 240 squared divided by 850. Alright, so we should, if that's functional properly, we should get a resistance of 67 ohms. Now we know what we're looking for. We can go and check the active and neutral terminals on the plug top, and we measure between them, and we should get there about 67 ohms. But something that we have to pay particular attention about is, let's put this circuit in as this toaster in as a circuit. So what we have here is a plug top, there's the positive side. Oh, let's say that's our toaster. And we're coming out, and there's a negative. Okay? So we're saying that the total resistance of this, by calculating it, is going to be 67 ohms. Now there's something the toaster has that we have to put in a circuit. So the toaster has a switch. Now if I was to measure the resistance of that circuit, I'm going to get open line. That's not what we want. So in order for me to get to 67 ohms, I'm going to have to close the switch. Okay? So we have to be aware of that when we're doing a test. Now our multimeter is still set to ohms. We're going to get the plug top. We're going to go across, so we are looking to get roughly around 67 ohms. That's what we calculated. Now I'm getting open line. That's because I didn't close my switch. So close my switch, keep it closed. Now, there's a connection unplugged up. Okay, I got 71 ohms. 71 ohms. Okay. So we're 4 ohms out. I'm pretty happy with that. So our resistance functional test passes. Alright. Now we move on to our next test. Insulation resistance test. Okay. Now this has already been calibrated, checked for calibration previously. But we will do a battery check again before we use it. Okay, battery's good. Take it off. Now what we do is we're going to set this to 500 volts. So all we're doing is we're going to check our active conductors down to earth. We want to make sure that the current is going to go where it's supposed to go. So what I do is I cross it, the probe, the active probe, across neutral and active like that, so I can use one hand. And then we can also get the other probe and we can touch it against the active probe just to see if the insulation resistance tester is going to show us a faulty reading. If there's first we'll turn it on. Here we go. That says the faulty reading. That's what we don't want. However, we're going to measure down to earth. So we're going to put it against the earth and don't forget to turn the toaster on. Cool. So it's on infinity ohms. That's what we want. Excellent. Don't forget to turn your insulation resistance tester off. Cool. Now the final test that we do is polarity test. However, we can't do a polarity test with a molded plug. This comes direct from the manufacturer. So we can't do that test, so that's fine. Alright, so just to recap the test that we did. Alright, first one we did was visual test. Then we did resistance continuity. And what we wanted there was less or equal to 1 ohm. Now don't get confused with 1 mega ohm. All we're doing is we're checking the continuity between the earth pin and any conductive parts on the appliance. Okay? And then we did the resistance functional test. Now the value we were looking for there was what we calculated using a power formula. R equals V squared divided by P. And then we did our insulation resistance test. Insulation resistance test. Now that value we're looking for was greater or equal to 1 mega ohm. So basically we were just determining if the current is going to stay in the conductors where it's supposed to. A bit like the plumber's doing a pressure test on his pipe. We want to make sure that nothing's going to leak out. We want to make sure the current doesn't leak out. Alright, and then the final test is the polarity test. However, we couldn't do the polarity test because of the molded plug. Alright, so that's how we do appliance testing.